Good morning or good afternoon, depending on what part of Australia you're in, and welcome to the Calix webinar. This webinar is about water management within mining. So that could be mining process wastewater. It could be water that's come off the land just as stormwater and ended up in a pit somewhere. And it could be any kind of other water that you're dealing with within the mining industry. So I wanted to cover a couple of topics. I might just switch over to the presentation straight away. I would like to just let you know that if you want to participate in the Q&A, it's worth logging into YouTube. You may need to use your Google account to do that. It's probably worth doing it right now so that when we get to the end of the video, you're not struggling to log in order to put your comment in, because you do need to be registered or at least logged in to YouTube in order to put comments in. So it would be great if you could do that. And look, let's jump into the presentation. There's a lot of information here. I'll try and keep it as brief as possible, but I think it's worth having a look at. So let's jump in. So water management in mining. What I wanted to talk about briefly today is the number one is who Calix is, because we are a fairly new player within the mining industry. What challenges there are within the mining sector, and how Calix deals with that. I'd also like to share a case study with a mine in central New South Wales that we did a lot of work with in order to tackle their water challenges there. And finally, I'd like to have a chat about ways that Calix can help you out to be able to reduce your chemical costs and potentially improve your ability to recycle, reuse, and maybe discharge wastewater or the water that you've got there as an environmental discharge, while keeping the costs low and maintaining that really high quality that the mining industry demands. Just before I go, this is actually a picture of our, I think it's here. This is a picture of our mine. It's in Myrtle Springs in South Australia. So we've got as a company, we've got a lot of experience when it comes to the mining industry, because we are miners ourselves. We deal with these challenges ourselves on a day-to-day basis. Calix is an Australian company. It was based on a simple but elegant idea from Connor Hawley, who actually built the first prototype of our technology, which is known as the Calix flash calciner technology. He built it in his backyard in Queensland. Mark Skeets worked with him to establish it as a technology and develop it to create a company that we now know as Calix. And we've all worked in order to make that technology a reality. So it's a simple but elegant idea. And we use that to discover new minerals, and that can be applied to a range of different industries. Before we move on, actually, just thought I'd let you know we are actually listed on the Australian Stock Exchange now. So that's happened in the last couple of years, which was very exciting. That's a picture of Mark and who else is there? There's a few people there on our at our launch for the ASX, our IPO. So that was very exciting for Calix. Calix is primarily a minerals technology company, and we're fully vertically integrated. So we own our own mine site and processing plants. Those processing plants are based on that core Calix flash calciner technology, which is used to create ultra-high surface area products, mineral products. The technology can convert really low-value minerals into a really high-value specialty mineral-type chemicals, and that can be used across a range of industries. We essentially own everything from the mine site through to the processing and all the way to the end. So we also do dosing units to be able to apply our solution, our technology to your mine site without any dramas or extra input. We're a multi-award-winning technology company as well, so we've been recognised across a number of different industries as for our success in sustainable technologies and the ways we've applied those to new solutions. Calix is at the forefront of the carbon neutral cement industry. We lead a consortium of the largest cement manufacturers in the world, and our aim is to create next generation a cement kiln based upon the Calix flash calciner technology. So, just thought I'd give you a bit of an idea of the ways that the ways that Calix apply our technology in different industries. We also make lithium-ion battery anodes and cathodes. So the technology, our core technology, is key to creating like the next generation of lithium-ion batteries. In partnership with Deakin University and a number of other private companies, private mineral companies, we're building the capability to do that right here in Australia, which is very exciting. We also work to improve how wastewater is managed through using the product of that process, those high surface area minerals, to stabilise the pH and alkalinity within wastewater systems. That accelerates the breakdown of organic components within the municipal and industrial wastewaters that we deal with. We also work with farmers and manufacturing plants in order to convert like solid and liquid waste into energy. That's done through anaerobic digestion, and we boost the amount of biogas that comes from that anaerobic digestion process. So essentially, we're creating energy and value from waste streams. And of course, I have to introduce you to our amazing team of engineers, scientists, and operators who really push the boundaries of what's possible. So now that I've given you a little bit of an introduction to who Calix is, let's talk about the mine water challenge. So the challenges that we often see within the mining industry. Mining is often done in dry areas, so Central Australia, those type of areas, back of Burke out in New South Wales, Western Australia. They are areas that are quite prone to drought. So, what are the ways that Calix can help recycle, reclaim, or reuse that water is primarily through acid neutralisation, heavy metal removal, and phosphate removal. By doing that, we also can significantly reduce your chemical costs related to if you're neutralising that water using something like caustic. We can come in and we can do exactly the same job as caustic, but at a much lower price. So, and there's also a lot of other benefits as well, which I'll come to a bit later. But let's touch on a couple of these other points, which are added benefits before we move on. So, as I mentioned, mining does often happen in fairly remote areas and dry areas. So there are these things called potential acid sulphate soils. What happens there is when you get drought or dry periods, the water table can drop and can expose the potential acid sulphate soils to oxidise them. What happens then is that they become acidic. They become essentially sulfuric acid. And that can leach into either into the water table or into stormwater, which then can potentially end up along with, whether it's stormwater within your process or it might be within the mine site. That can really drop that pH within the water systems that you're dealing with. So that cycle of drought and then a lot of rain can wreak havoc to the water systems within the mining industry. Phosphate's another challenge. So we've come across a number of situations where the phosphate or orthophosphate level was high, soluble phosphate. What that can do is it can end up with can result in blue-green algal blooms, whether it's in waterways or environmental discharge, or even in the wastewater ponds that you're collecting to potentially reuse or recycle that water. What we can do is we can actually remove that phosphate using the same method that we use to neutralise the pH within the systems. So I'll come to the way we can do that a little bit later on in the presentation. But primarily it's around neutralisation. Acid neutralisation is really the key benefit here at a low cost. Let's have a chat about the customer success story or a case study that we've had. This is a mine site in central New South Wales. They had a drought in New South Wales, which was wreaking havoc with the local town water supply. They were running quite short on potable water, which essentially means the council had to come to the mine site and say, look, we can't provide you with any more water because we're down to 2% storage. So you're going to need to find a way to get water on your own. So they came up with a way to recycle the water that had accumulated in one of their pits. They were trying to treat that with caustic, but I'll come to why that was a problem in a minute. But essentially, they needed to treat that mine water, try and knock out the heavy metals and get the pH to the correct value before they reused it within their process, recycled it within their flotation process. So that heavy metal removal and the acid neutralisation was critically important. Wouldn't mind just stopping here for a second. So just saying, if you've got any questions as we're going, please this is a live event. Please make sure you drop the any questions in the chat as we're going, and I'll get to the end and just have a look back and see if there's any questions. Doesn't look like there's anything there yet, but I'll make sure I keep an eye on that as we're going. So anyway, so this mine in central New South Wales, they had a couple of pits. They were pumping out from an underground mine, old gold mine that they had there, and they were putting it into this pit. That old gold mine had obviously very dried out, and the acid sulphate soils had leached into the mine water. So as they were pumping it out, more acid was kind of coming into the system, which was causing some problems. But again, Calix has the solutions for that. They were trying to solve this with caustic. However, there were a few problems there. I'm right. So the challenges with caustic in this specific case was that the discharge of caustic from the tanker into their pit was a real challenge. So there's challenges with safety with caustic. It can cause quite severe burns, whether it's on your skin or even worse in your eyes if you get it in contact with you. Adding caustic to water is also a major problem because there's a heat of mixing with caustic when you mix it with water. So it can actually boil the water if you're not carefully mixing or getting the ratios of the water and the caustic right, or at least having somewhere for the heat to flow to. So they're actually having to inject the caustic into this. You can see the pipeline on the left-hand side there. The tanker was discharging into that pipeline, but they're having to do it neat. As in just pure caustic. The reason they had to do that is because it's a plastic pipeline. So if they mixed water and the caustic together and then injected it into the poly pipe or the plastic pipe, there's a good chance that the pipe might melt because the heat of mixing with the caustic can cause that water to heat up significantly. So what they were having to do is add that in as a pure caustic, which means they didn't get the dilution or mixing as it went down into the pit. Caustic has got quite a high density, so there is what we were suspecting. Like they were adding a lot of caustic, and they weren't achieving the pH change that they were expecting with the amount of caustic they were adding. What we suspect is because the caustic had a density of about 1.5, as it was being added into the pit as a pure caustic and not mixed well, that high density was causing the caustic to go into the pond and just sink straight to the bottom. And unfortunately, there's no way they could get around that because you can't spray it out because it's quite dangerous. It's got an incredibly high pH, which means that if if somebody walking by a spray copped a mouthful of it or copped a spray, it might be quite severe problems for their respiratory system if they breathed it in. So that was a bit of a challenge, and also the pH longevity. Although caustic's got a very high pH, the alkalinity is incredibly low. So when you add it, you get this high kick of pH, but it doesn't stay there for very long. As soon as the biological processes take over, what happens is that they consume that high pH, and it ends up dropping the pH straight back down again, which was a bit of a challenge as it was going down the pipeline. By using ACTI-Mag, you solve that because ACTI-Mag's got the other opposite conditions. ACTI-Mag, which is it's a magnesium hydroxide based product that we produce. It's got a relatively low or relatively neutral pH, but a very high alkalinity, which means you get a lot of value for money out of it. It's got very good in terms of longevity of that pH change. The challenge they faced here, essentially what we did was we added ACTI-Mag into a pit, into the pit that the water was being pumped to. ACTI-Mag is fast acting because it's made with our unique calciner technology, which means it's got a really high surface area. That high surface area allows it to react with the acid a lot faster, which means it neutralises the system a lot faster. It's very good at adjusting the pH because it does have that fast-acting high surface area, and it's also very good at lifting the alkalinity while not injecting hardness into the water. So low solubility of magnesium's got an incredibly low solubility in water, which means that when you're adding it, you don't get the hardness, you don't get the scale that other products like lime or other alkalis can cause downstream if they dissolve in the water and get carried through into a process. So you get the improved alkalinity without the water hardness and the significantly improved pH or the neutralised pH. Side benefit is that you can also capture iron just using that pH change and other heavy metals, but also phosphate. Our product is quite unique in terms of it's able to capture phosphate, and I'll go into the mechanism in just 1 second. In terms of handling, it's really easy to use. So it comes onto your site as a 60% slurry. That 60% slurry is really easy to handle. It's very stable. We usually put it into a conical tank and keep it agitated or keep it mixing turned over using just a recirculation pump. It blends very easily when it's added into a pump well. So it's a 60% slurry in water. So there's no need to mix it up because it is being carried by water. There's no wetting or anything required. So because it's already hydrated, it's already wet, it's already in that slurry solution. Essentially, you add it in and it gets mixed in by the pump as it's being discharged from the pit. There's also no heat of mixing like alkalis like caustic, which means that it's okay to use in plastic pipelines. And there's no build-up of solids in pits or in pipelines due to the fact that the acid within the systems actually consumes the solids. So as the product is used, as it neutralises the pH, it consumes all the solids that are in the system, and that way you don't end up with any silt or anything in the pipelines, which is fantastic compared to something like lime, where you can end up with silt increasing the pressure on the pipeline. So real benefit there. So our solution is ACTI-Mag, and I wanted to talk about a couple of ways that ACTI-Mag can help. The first one really is cost savings. So this is a significant one. We've got an online calculator that demonstrates how much you can save. Say if you're using caustic, you can work out exactly how much money that you can save over the long term. It does range into the millions of dollars for some places, which is fantastic. And as you can see on the side here, the chemical usage for magnesium hydroxide or the ACTI-Mag high surface area magnesium hydroxide product is significantly lower than other alkalis. Magnesium hydroxide has 2 alkalis, whereas other things like caustic only have 1 per molecule. So ACTI-Mag gives up twice as much alkali or neutralises twice as much acid for the same number of molecules, which is fantastic. You can get significant savings when it comes to replacing something like caustic, or whether it could be soda ash or any other type of alkali with the ACTI-Mag within your system. ACTI-Mag, it's really safe to handle. It is a non-dangerous, non-toxic, non-hazardous product. You can get really accurate pH control with it, thanks to that significantly higher alkalinity than other types of alkalis. You can capture that phosphate and heavy metal removal, which is a real great side benefit if you need to remove those things before you recycle them into your process or discharge that water as an environmental discharge. Reduce those chemical costs and reduce scale and potential algal blooms. So the safety is often one of the reasons that mine sites come over to using the ACTI-Mag as opposed to caustic. Caustic has got a very high pH, which means that contact with skin is a major problem. It can cause it dissolves fat and it can cause fairly significant burns very quickly. And it doesn't hurt like acid, which means that people can get it on their skin and not even realise it for a period of time, and all of a sudden, they've got a hole in their hand from the caustic burn. ACTI-Mag, on the other hand, is a product made with magnesium hydroxide. So, as I said before, it's got a moderate pH, fairly neutral pH, not completely neutral, but much lower than caustic. It's got a really high neutralising capacity, that alkalinity, but you do a Google search for it online, and it's used in cosmetics. People deliberately put it on their skin. So there's no chance of getting caustic burns or lime burns or anything like that from ACTI-Mag. It's incredibly safe. On some cases, I actually have a little bit of a drink of it. There are products on the market which are antacids to help your stomach with digestion. So people do consume magnesium hydroxide as supplements or additives within their diet sometimes. I wouldn't recommend eating it because it doesn't taste great, but it's significantly safer than other types of alkalis. Wanted to give you a quick rundown on this is a case study at a potato chip factory. This is phosphate. So essentially what we're able to do is we're able to knock out or capture the phosphate within the solids portion of any wastewater system. This particular place was using ferric chloride, and we were able to significantly reduce the amount of chemical needed in order to remove the orthophosphate or soluble phosphate from the liquid and put it into the solids. There's another case study we worked with an abattoir in Tongala in Victoria, and as you can see here from the graph, we're able to significantly reduce the amount of phosphorus or orthophosphate within the water and deposit it in the solids, in the sludge. So that was a great result. The way the phosphate capture works is that the ACTI-Mag, thanks to its really high surface area, it can form these complex molecules with nitrogen, magnesium, and phosphorus. That's called struvite. A lot of people, when they hear the phrase struvite, they think about pipe scale because if you have very high levels of phosphate within a water system, what can happen is that phosphorus will react just with the natural magnesium and nitrogen within the water and form the scale when it's inside pipes. But what we do is we use the ACTI-Mag. Thanks to that high surface area, we can actually do that reaction, capture the phosphate and the nitrogen actually inside the particle, and then that particle can be separated from the water stream. So whether it's done through cyclonic removal or it could be deposited through clarification or settling, you're able to remove that phosphorus from the water stream just as a solid, which is the struvite contained within the ACTI-Mag particle. We do have a webinar that I hosted a little while back that's listed on YouTube that goes into the details about how we capture the phosphate and the side benefits that you get from capturing phosphate and the phosphate cycle. So if you want to have a look at that, or if phosphate's of interest to you, it might be worth going back and having a look at that one. One other benefit is that it is fantastic for odour control. So we're able to reduce the amount of hydrogen sulphide that's generated from an anaerobic system. As you can see here, this was a municipality in southern New South Wales. They were using calcium nitrate in order to capture or contain the hydrogen sulphide that was being generated. So that hydrogen sulphide was peaking up somewhere between 50 and 100 parts per million, which is, still relatively high, but that we shut off the calcium nitrate system, and as you can see, the odour just the odour and the hydrogen sulphide levels just skyrocketed up to 300 to 350 parts per million. We started the trial, and that plummeted. The hydrogen sulphide levels plummeted essentially right down to below 20, which was fantastic, well within the allowable limits. So if you want it for hydrogen sulfide control, ACTI-Mag works wonders from that respect. If you have clarification within your process, whether it's filters or filter presses, ACTI-Mag works as a mild flocculant as well, so we don't recommend it as like a replacement for something like a polymer or a flocculant. But if you're adding it to your system instead of another alkali, or if you're adding it to your system instead of something like a ferric chloride or something to remove, or alum, in order to remove the phosphorus, the ACTI-Mag is able to increase the density of the sludge within those processes. So things like alum tends to make the sludge or the solids puff up a bit. So if you're doing a separation process, you won't get as high a density out of the bottom of clarifiers or cyclones, and also you can end up with significantly more solids. So if you're transporting those solids, the costs go up because of that as well. ACTI-Mag works in the other way. So what it does is it acts as a mild agglomeration just due to the dipolar nature of the molecule, and that attracts everything together. So you end up with a sludge density that's improved. So if you have one of those systems within your wastewater system, then ACTI-Mag may be able to help there. So to summarise the benefits, really, reduces chemical costs, it gives you accurate control of the pH, boosts alkalinity. So as I said, that really long-lasting alkalinity while maintaining a decent pH. It reduces struvite scale build-up. So if you've got a problem with phosphate scale within your process, ACTI-Mag can help to knock that soluble phosphate out. It's really safe to handle, non-dangerous, non-toxic. You knock out those heavy metals, the phosphate, reduce the hydrogen sulfide and odour if that's a problem within your system, and if you're using it instead of caustic, you're also reducing your sodium added to the system. So that way you're not adding sodium into the wastewater or potentially into your process if you're recycling it. We also do dosing units, whether it's purchase or lease or rental. We can provide a dosing unit which is specifically designed for ACTI-Mag, and the size scales up and down depending on the end user application. So all of these are designed and built in Australia to meet the really high standards of the mining industry. So you can feel confident that we can essentially take our product and deliver it without any problems, solve the pH challenge that you might be facing, solve the challenges with heavy metal removal or phosphate removal, and there's no headaches, there's no handling headaches, there's no safety headaches. So that really summarises the system and the technology that we've got with the ACTI-Mag. Before I go and take questions, I wouldn't mind just saying that I wanted to say that Calix is a proud sponsor of WaterAid. WaterAid is an amazing organisation. It's a charity that works across the world to provide fresh drinking water and sanitation to those who really need it. As a WaterAid ambassador myself, I'm participating in the Walk for Water. That's up in the top corner there. That's me going for a walk in Sherbrooke Forest the other day. Essentially what it is, we go for a walk for 1 hour each day in solidarity of those around the world who have to do that every day of their lives just to get water. So if you've got if you can spare the change, please consider contributing. It's a fantastic cause. I'll make sure I put links in the description of this video so that if you're coming back to it at a later date, you can potentially donate. Otherwise, just do a Google search for WaterAid Walk for Water, and link to the Calix, the Calix contribution. That more or less finishes the presentation for today. So let's flick back and maybe take any questions. Just grab my phone here to see if there's any questions that have come in. It doesn't look like it. So if there's nothing else, I might thank you for attending the webinar. Or if you're watching it later on YouTube, please add some comments. If you think that we can help you in any way, whether it's, as I said, through the reducing the costs for the alkali chemical additive, it could be through that pH adjustment, or if you're just looking for a safer alternative, it's definitely worth at least getting in contact with us. You can jump onto our website at calix.global, www.calix.global, or you can email myself. I'll make sure my email's in the description below in this video. Or you can just jump on our website and get in touch via our chatbot. I say chatbot; it's actually our marketing person, Audrey. She works on the contact side of stuff. So if you wanted to have a chat, just jump on the website and put in your details, and we'll make sure we get in contact with you and have a chat with you about ways we can help. I'll just double check if there's any more chats. No, it looks like that's it. So, all right. Well, thank you so much for attending. I really appreciate your time, and hopefully we'll talk to you soon. Thank you. Calix sources magnesite from around Australia and around the world, including our mine site in South Australia at Metal Springs. We control the local supply chain, so that gives you confidence around continuity of supply. The next step within the process is we take this magnesite rock and we convert it into a powder for processing. The first step of the Calix process involves taking the rock and grinding it and crushing it down to a very fine powder. We then sift that powder to create a particle size distribution that's ideal for end product stability. This is the Calix CFC calciner. It produces an ultra-high surface area magnesium oxide powder to create your products. It's also built around sustainable principles. So it has the capability to capture carbon dioxide as a part of the process. This technology is core to the Calix purpose of solving global challenges, being used to provide environmentally friendly products and has the potential to capture carbon emissions from industry. Calix has ACTI-Mag hydration plants like this around Australia and around the world. That way we can produce the ACTI-Mag and magnesium hydroxide fresh for your process. It also means that we've got experts who know about the product locally in your area to help you along your journey to switch to ACTI-Mag to maximise your process. Calix sources magnesite from around Australia and around the world, including our mine site in South Australia at Metal Springs. We control the local supply chain, so that gives you confidence